Hello, class. This will be the recorded lecture for section 9.3. And this is, again, a hypothesis testing. And it's following the same pattern as we did in chapter 8. So remember, the first one that we did was this idea of using z-scores, right, as the critical value, or these p-values calculations. And that was predicated on the fact of a large number of samples plus knowing the population standard deviation. In this section, we are not going to know the population standard deviation and a possible of smaller sample sizes as well. If that's the case, the t-score is the preferred critical value of choice in the hypothesis testing. So I think the good news is that it is a very similar calculation. You just got to keep track of, let's see here, I can't get to the right, there we go. Let's start here. And so we're going to do, there we go, hypothesis testing with population mean will be known, but the standard deviation is unknown. And so that implies t-scores. So if you see here, let's take, we're going to use this as an example. So there were 76 subjects, and they're going to see if there's some weight loss or not. So after 12 months, they found that the weight loss was 2.2 kilograms, the average of those 76 people. And they did the sample standard deviation for us, which was nice. And there you go, 6.1 kilograms. And so the question is this weight loss work? So the null hypothesis would be our mean is 0, right? And it would be greater than 0 if you actually lose weight. So that's how we'll set it up. And you say that if we knew the population standard deviation, we could use our old z-score calculation for our test statistic. But you can see here is our test statistic using t-score. So it's exactly the same concept. Instead of the population standard deviation you plug in, you instead of that, you just plug in the sample standard deviation. So let's walk through the calculation with this one here. So we have n equals 76. We had the mean calculation of 2.2, and that's in kilograms. And we had our sample of standard deviation, 6.1. So remember, when we do this calculation here, our t-value, which is our test statistic, is x minus mu over s square root of n. So when we set this up for this calculation, we have it set up where h of 0, we're assuming no weight loss, and if it works, it'd be greater than 0 weight loss. So this is the right tail. And so we're going to set our probability of there, and typically you like to set it at 5%. That's the alpha that we set up. So let's do the comparison with regards to t-score, all right? So the t value here will be 2.2 minus 0 over 6.1 divided by square root of 76. So you look at that, you get a number of 3.144. So again, if you think about what the t-score looks like, and it looks like that, it's a pretty big number up here, right? And so you're thinking that it's probably going to be less than 5% here. That's our goal. And so how do we compare that? Well, one way to do that is to pull up the z-score table, and that's what we're going to do here. And just to remind you that the degrees of freedom here is n minus 1. And so that would be 75. So if we take a look at the z-score table that I uploaded to our Canvas account, got to hit the right button. There we go. And so we're talking about a one tail And so it would be 0.5, right, for the upper tail. So we'll use column 1, that's 5%. And we go down to 75, and we get 1.6652. So if we go back to our whiteboard, again, just like on the z-score, this would illustrate that 1.6654 it was. Just try again here. 1.6654. So that is 5%, all right? And so you could see that this is less than 5%. So we could say we can reject the null hypothesis. That's, again, the strategy. So if this t-value is greater than that t-value, then we'll be able to reject the null hypothesis. So the question is, what is this probability, right? What is that? And we call that the p-value, right? Well, we'll show you how to calculate that using technology. But I could show you that you can do a pretty good estimate. And so if you go back to the t-score table and we look at the 75, right? Well, let's find a number that's close to that, right? And so you could see that, okay, it looks like it's in between these two, right? 3.2 and 3.4. And so if you go up here and look at these tails, you can see these tails are quite small, right? This single tail, that's 0.1%, and that's 0.05%. So you could see that by just an estimate using the t-score table, right? Oh, 3.14. So why don't we use the, sorry about that, we'll use the 3.2. That's close. And you can see it's still less, it's going to be 1%. So you figure that this thing is going to be between, not 1%, 0.1%. So you figure that, let me draw this over here again, give me a little bit more room. So if we blow that tail up here, and this is 3.144, if you looked at, say, 3.2, that would be 0.001, and then if you want this a little smaller, that would be 0.0025. So you know it's somewhere in between there, which is way less than 5%, right? So you can see that not only by the t-score comparison, we can reject the null hypothesis, we can reject it strongly because the probability, or that number that we get with our t calculation there of 3.144 is very small. So when we do this, though, we do have a couple criteria that we have to meet, and they're hopefully pretty straightforward. And you could see that with technology, it ended up being 0.0012. And I'll show you that in the next recorded slide, how to use technology to find that. So a couple things, just to reiterate: random samples and n greater than 30. If it's not greater than 30, t-scores are definitely used again. And you're going to assume or try to prove that it's kind of approximates a normal distribution. And then the other things that we want to take care of is, again, remember that the degrees of freedom, n-1, and these right tail, left tail, two-tail test. Same thing as before. When the null or the alternative hypothesis is greater, it's right tail, less than is two tail, and not equal is, or less than is left tail, excuse me. Greater than is right tail, and not equal is two tail. So that ends the recorded lecture for using t-score critical value calculations. The next one, I will show you how to find the p-values using technology.